Hello and welcome to the latest APAC Hybrid Cloud Kopi Hour. Super exciting to be back here. Where I think it's only been a couple of weeks since the last one, so it's super cool to be here. As always, I like to introduce the fact that we are the Kopi Hour, which is this wonderful coffee beverage you can get in Singapore that I do so love. My name is August Simonelli. I am a technical marketing manager here at Red Hat. And I am so excited to be rejoined by my co-host extraordinaire, Dev Schonbag. Dev's been away on vacation. So no, it's really great to have you back. How you been, Dev? Say hello.
Hey, August. Really good to be back and joined in the show. Looking forward to another awesome episode of the Kopi Hour. Cheers to you. And just have the ability to have Prakhar and Tyrell present some really cool stuff with us today.
Yeah,
So yeah, over to you, Prakhar.
yeah, definitely. So we met Prakar last week. So Prakar Sivastava, go ahead and say hi again. Yeah, just introduce yourself.
Yeah, thanks, August. Prakhar, we met in our last episode where we talked about event-driven Ansible. So today we will be focusing on something related to security. So, as my introduction, I'm working as a team lead, principal architect for Red Hat Demo Platform team. There's the T-shirt which I'm wearing today. For that, we showcase the capability of all our products by aligning them with the marketing messages and assist our sales by developing the demos for them. So there, we basically develop the sales assets. So yeah, that's our working.
That's right.
Thanks.
And we are also joined today by Tyrell Reddy, who is on Prakar's team. And so that's super exciting because we're getting like all our gurus in one shot like last week. Tyrell, say hi.
Hi everyone. So my name is Tyrell. I'm with Prakar's team. He's mentioned most of what we've done do already, so I won't bore you. Yeah. So we within the demo platform team, and we just going to show you one of our demos that we built today. Yeah. Over to you.
That's awesome. So I noticed you've got the shirt on as well.
Yeah. Oh yeah.
So and Dev is wearing his Red Hat shirt. Now I decided to go bold here, and I've got my OpenStack shirt on. That's right. That's right. So that's right. I've got the OpenStack shirt on.
Yeah,
So
we just announced OpenStack on OpenShift. So
well, there
why
you go. There's a future show.
so you have OpenStack, we have OpenShift. So
Yeah, so we have all the stacks and shifts,
All
so
in
it's
family.
wonderful. But yeah, I decided I found that in the closet, and I thought, you know what, that's going on. So before we kick off, I want to in our description for the episode, we teased an article that you guys wrote, and I wanted to call out a few things that I saw in there that I found really interesting. So I've put together one of my little slide decks that I wanted to do. I want to talk about some of the numbers I saw in there, and they're numbers that both you, Tyrell, and Prakar will recognize. So, but I kind of wanted to highlight them and sort of address what they mean. So the first one is 49. This one jumped out to me. What is it? 49. Well, that's simple. That's the number of vulnerabilities that you guys say was from the study that's listed in the doc in the average application. 49. That's pretty rough. And that you also mentioned that there's 80 direct dependencies in those applications, which is like you start to realize the complexity of what developers are dealing with when they're trying to actually create this stuff. So I continued reading and I thought, that's scary. And then the next number that popped out was 4.45. Oh, there's a lower number. Maybe it's not as bad. Problem is, you guys mentioned that this is the number of million US dollars that the average total cost
yes,
is
yes.
associated with a data breach. That's scary, right? I mean, we're not talking couch change. We're talking a problem here, and an area where the complexity in software has created a financial issue that needs to be addressed. So I kept reading, and I'm thinking, well, okay, here's another number, 83. I like that number. I love the number 8, but then I read on and I learned that it's 83% of organizations have experienced more than one data
More
breach.
than
And I'm not totally surprised by that, but it is like you really start to think, oof, that's not good, right? So you can kind of see the doom and gloom story is mounting. I thought I got to find something good in this. So here's something good. There's something that's rising. And then I looked closer and I read what you guys said, and it said that the study also found that the rise of artificial intelligence is further making this complicated. It's increasing security breaches.
Yeah.
So we've got all this stuff. It's costing money. There's lots of exploits. Everyone's seeing data breaches. Then I saw this 70-20. And I know Picard and Tyrell, they're looking at that and they're going, 70-20. What is that? Well, this is probably one of the harder ones. And I really wanted to call this out. That's how badly my team lost this week. So, yeah, I'm a fan of the Denver Broncos in the National Football League. They actually got destroyed by Miami. And so I felt, we needed to bring in, if we're talking doom and gloom, I'm bringing all the doom and gloom in. But you know what? I'm not worried because who do I have on this call? I got the heroes we need to fix this. I don't know if you can fix the Broncos. I would love it if you could. But what I do know is that you guys have come to tell us a little bit about how we can deal with the scary situation that is going on for security and the products that Red Hat and basically the open source community has to address this kind of stuff. So I will actually share the blog post address there for folks to take a look at. But with that intro, I'd really like to kind of learn more from you guys about how we're addressing this at Red Hat.
Cool. Thank you. See, so let's. I just want to show some slides with some more numbers. So let's talk about that a bit.
Yes, and I tried not to take any of these numbers, and I'm sure you don't have the Broncos in there, but yeah, there's plenty more good numbers.
Yeah. Okay. So we have a big agenda today, which we will be talking about. So I'll just start with the stuff which. Sorry. Yeah. So we'll start with what is software supply chain security. Okay, so we and why it is very critical. Like August had just thrown some numbers that 80% of organizations have already faced some kind of breach. Now, most of these breaches are due to the dependencies which the libraries which they are using, the sources from where they are getting those libraries, and they don't know exactly where those libraries are coming from, especially when the companies are more and more relying on the open source softwares, where they don't exactly know which source from where that particular library is coming from. That place of software supply chain security becomes really, 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 really critical. So we'll start from there. Then there's an executive order by US government for the software supply chain. We'll talk about that, what they want to do, and what we can learn from that particular in executive order. Then we'll start talking about bit of the developer flow, so how the developers work in, and then we will talk about the shift left strategy, which is again part of the developer flow. So how we bring security in the early stages of development cycle. So this is something which we'll talk about. We'll talk about the code build and monitor. How are the tools which we are using and which Tyrell will be showcasing in the demo. We is to protect our softwares and our customers can learn from out of that. I'll talk about the bit of the high level architecture, what we have built as for this particular demo, and which clusters are running, what tools which we are having in on which cluster we are running it on, and then Tyrell will showcase the whole demo for you. So let's start from what is software supply chain. So okay, so that's okay. Okay, so I'll start with the when we talk about software supply chain security, we always discuss about DevOps, DevSecOps. So starting with DevOps or DevSecOps, which is basically DevOps on steroid or DevOps which is boosted by the security. It is blending the teamwork and automation development with all the security practices. So this is one way of looking at the security. When we are bringing security into the into the developers development cycle, then what is software supply chain in that case? Then so software supply chain is basically, it's about ensuring each and every software component which our customers, which organizations are using, and to check their authenticity, to verify that they are safe to use, verify which source they are coming from, how to, and once once our developers write the code, we make sure that that particular code has been gone through some scrutiny, they have been tested, they have been signed by that particular person who have done that. Once we build up the images, we know that that particular image was built on a authentic base image, maybe the universal base image which Red Hat provides, which has been already been tested for all the security measures. And then after they use that as a base image, they put their applications on top of it, then we sign those particular things. So that is what all about the software supply chain security, that every aspect of your development cycle, we built security on top of it. Let's Okay, so that was the DevSecOps and both the concept which I was talking about, so where we are combining the principle of DevOps and also the security, which is we are boosting its security. And software supply chain is basically looking at each and every software component which we are having, and especially when you are using the external libraries. The thing which is we have to think is every organization in current world is somewhere using a OSS or open source software, and they don't know from which particular source they are downloading. They can download a developer can start writing a code by just downloading a binary from internet, and he doesn't know why it's been compromised by somebody, or it's been already been have some malware in it. How to trust it? So that's what software security is about.
And it's a good point, right? Because you think about even the way, like, I'm not a developer, but as I learned and I'm cutting and pasting code, and I Google and I find that something is, how do I do something in JavaScript or something, and I cut and paste and I copy. I don't check all these
Yeah.
things, and so with all this great open knowledge, which is great, mistakes happen. Even if someone's not trying to be nasty, we want to find things that aren't right. So you start to realize how complex this can get.
Yes, true. So let's talk about why this software supply chain, as August was saying, that we don't really sometimes care which source we are just getting that particular library from. So why it is important? Now, when we say supply chain attacks, it's about when they will happen, not if they will happen. Okay, so it's they are all the numbers which August had thrown in front of us shows that how much security attacks are happening, how much dollars we are losing. Like $4.45 million in 2023, which was in 2022 it was 4.36, which is now 2.6% increase in that particular attack. So we have already lost that. So this is something which we have to take care. Even after paying the ransom, the real cost is the downtime and the recovery. So okay, we what happens when we are attacked? Basically, they ask for ransom. Okay, we pay for ransom. But what about the downtime? What about the recovery from the data breach? And how will you know that after even paying the ransom they have provided all they are not releasing all the data of your customers? So very difficult to. That's why the software supply chain security is very important for us. Now here are some more stats, more numbers. There has been 742% average annual increase in these attacks over the past 3 years. Okay, which is a big number. And 20% of these data breaches were traced back to the compromised software supply chain. And because our developers, they just use a library which they don't know from where it is, so that's like 20% of those breaches were just because of those compromised software supply chain. Now, 78% of the now the good news. Now, the good news is all about the bad news. Now, 78% of the organizations are looking for collaborating the DevOps and security teams together. They want to work together. They want to find out that what can be done to protect from these attacks. And 92% of organizations believe that all the OSS solutions are pivotal for the transitions to moving to the open hybrid cloud. Okay, so that is something which we need to look at. That's the good news for us. Like people have started thinking about it. People started talking about it. So at least let's see how we apply all these things.
Right. And we're not calling into question open source. It's not like people are saying, well, we're not going to bother with open source. It's like we need this. It's a proven model. It works. Let's make it better.
Let's make it better. Yep. Okay, so no numbers now. Okay, the growing attacks. So let's talk about some attacks which happens. Like our digital landscape is increasing. We are getting AI. We are talking about ChatGPT. We are sending all those messages. So threats are also increasing. We are seeing security. So now security supply chain is not just a buzzword. It is crucial for protecting data, intellectual property, source codes, and let's quickly highlight some of these threats. Like stolen certificates, still a very significant threat. People steal the certificates. Type typo squatting attack. Simple. Instead of typing maybe Bank of America, you just say Bank O America. Simple, and then you go reach to some place where your attacker is sitting out there and looking for your username and password. Dependency confusions. A lot of the times they are ambiguous dependencies which people use, which can be exploited. Compromise build environments. Like I was saying, that when you are using your build environments like a base image, and instead of using it coming from a trusted source like UBI image from Red Hat, you're using somewhere from some other third party registries. You're downloading a base image and you don't know what that image has. Pre-installed malware. So risk before we begin our development. So before we start beginning our development, before we start writing our first line of code, you already have a malware installed in your base images, and or any malicious firmware code. So these are subtle but deeply harmful for all these attacks. So that's something which we need to take care, and where our software supply chain security comes in to rescue.
It is quite an exhausting list. It's kind of covering, the source, the packaging, the build part, right?
Yeah.
I mean, I was just thinking, and I don't blame the developers, when you do an NPM install, it has, 50 to 500, dependencies.
Yes.
It is easier for the developer to, get to a particular point, but, how much do they, rely on this, all these dependencies, and whether they are protected, they are secure, that comes into question. So really interesting. Yeah.
Hmm.
Yeah, that's what we are trying to bring in is developer needs to understand from where that particular library or dependency he is downloading, and also when the auditing team comes in, if there's an attack happens, like it's you can't stop it. You can prevent the attacks, you can slow them down, but you can't just stop those attacks. But at least if we know the reason of the attack, next time it will not happen. So that's something which we are looking at in the secure supply chain, where we
Yeah.
want to
So what
secure
you're
it.
trying to say is it's always evolving,
Yes.
and
I think we
Yeah, it's quite a. I mean, that's a great call out, Dev. Is that it's complicated and evolving. So, I mean, I haven't heard of half these things, and I know what they are. Like, Carl, when you explain them, the typo squatting with a great name. But yeah, we do this show in a month, in 3 months, and that list has changed and
yes.
is longer, and so yeah, it's insane.
Okay, so it's not just us who are worried, even the governments around the world are worried. So again, the US had just done an executive order, which is 14028, which is enhancing the cybersecurity. It is basically a security standard for software purchased by the US government. NIST is the key player which is charged to boost the security measures. They are creating guidelines for mainly for US agencies, but we can learn from the same standards that how we can make our software supply chain more secure. So we are just learning from those standards which NIST is trying to make as well. And our aim is to if the viewers who are listening to our live streaming, if you are guys are working with US agencies, if you're working on the projects which are based for the use of US federal, especially you need to read about this executive order. You will find out the framework, how the cyber how you can secure your software supply chain. So that's something which is very interesting. Go through it, read through it. Some of those good things we learned in Red Hat, and we are trying to implement that in our secure supply chain approach. Okay, so after, what is the Red Hat take on trusted software supply chain? What we do now, first of all, over the 3 decades, we are distributing the software. We learned from the best how to distribute those softwares. Now everybody knows that we have Red Hat package managers, which is RPMs, which we are distributing to our customers using Red Hat CDN, Content Distribution Network. How we ensure that those packages, when they reach to the our customers, they are reaching in they are coming from a trusted source. So what we do, we sign those RPM packages with GPG keys, and we provide the GPG keys to our customers. So before they install those packages, they they verify those packages with our GPG signatures. We have then we started working with a disconnected environment. We got satellite server. We asked them that, okay, if you are in a disconnected environment, you can connect through to the Red Hat CDN from Red Hat satellite, and you can locally get those packages from satellite. Now, satellite not was not just to distribute the packages. We also send notifications. We send if there's a new CVE comes in, and we patch one of our applications, we immediately report it. And satellite itself will show you that these are the servers which are basically affected by that particular CVE, and there's an automated way of patching all those servers using satellite. So we have implemented all these security measures in Red Hat from and built them from last 30 years. We clone all the code from to our internal repositories first for the control. Our distribution is rock solid with the by the signed packages I was explaining. We have implemented the robust safeguards against any tampering. So if anybody tries to put any malicious code in our RPM, those signatures will say, oh, this particular RPM package is not signed by Red Hat. It is coming from somewhere else. So I'll not allow you to install it. And we maintain our products with minimal changes, ensuring that protection against any unpredictable code risks from the upstream. So we try to do all these things. And now what we want to do is we want all the stuff which we have learned in last those 30 years, we want to bring that and make our customers to learn that from us. We want them to share the knowledge which we have gained in last 30 years to distribute those packages. We want to share the how we do it in internally, and then how our customers can benefit from our experience. So this is what we are trying to do in here.
And I think this also highlights that for especially for Red Hat, security is not the end of the story. It's not like we build something and we test it and then we deploy it and then we secure it. It's more like we secure and then we build and we secure and we test and we secure. Like it's happening at every stage. And I think what you'll see with the demo and with as Prakar keeps going is that that's where we're extending this, like he's just said, into that next space. Every step of the way, there's secure.
Yeah.
It's not sequential. It's there. It's just there. It's not even rinse and repeat. It's just always part of it.
Always part of it. Yeah. Okay, so let's take you towards the stuff which we want to show you in the demo, which Tyrell is going to showcase. So before Tyrell starts, I just want to bring a few things in here. First is the developer flow. Now, developers always operate within two distinct cycles. One is the inner loop and the outer loop. Now, most of the magic happens in the inner loop, where coding, immediate testing, debugging, it's where the developers are having their immediate feedback loop. And then we have the outer loop, which encompasses from integration testing to deployment to security, monitoring in production. So that goes in the outer loop. Now, if you see here in the outer loop, the security is in the outer loop, where security traditionally we keep security at the end of the development cycle, which we want to change. We want to bring the security from the point when the developer starts writing their code from their IDE, from their favorite VS Code, or from their favorite Nano or VI or whatever they want to use as their IDE. So we want to bring the security in there. So that's something which we want to talk about in today's session. Now, one of the major things to bring security in the inner loop is the shift left strategy. Now, when we are discussing the developer flow, we look at the shift left strategy, which represents the transformative shift in our approach to security. Now, rather than addressing the security at the end of the development process, we want to bring the security in the starting. As I was talking about, as soon as the developer writes his first line of code, we want to bring the security. Now, this strategy naturally complements our inner loop where coding, testing, and debugging is taking place. Now, by shifting security left, we embed the security considerations directly into this initial loop. Now, the outcome, potential vulnerabilities are identified and addressed much earlier in the development cycle, or we just don't wait the product to be out. We are not waiting for that. So, in essence, shift left champions a proactive approach, embedding the security aware development right from the beginning. So, that's something which we want to showcase today. Okay. Now, catching dependencies and vulnerabilities early. So, code integration with application security. So, as I was talking about, now one of the aspects of our approach is focusing on the transitive dependencies. There are indirect dependencies in the software. They can be potential security gaps, like from which libraries, which dependencies we are using. Now, imagine as a developer when you're writing the code in your IDE, and there, if you get immediate feedback, oh, the library which you used is having this particular vulnerability. You can immediately say, oh, I don't have to use this particular library. Let me get the library which doesn't have this particular vulnerability. So that's what we want for you. So as soon as the developer writes his code, he will find out, he can scan his code, he can figure it out that all the stuff which he had used in his application is vulnerability free. There's no vulnerability inside it. So this is what we are trying to bring with our secure supply chain approach. So we are not just waiting for the post-development scan, we are proactively flagging real-time issues in the developer's workspace. So when developers are writing their code on their laptops, they know that the code which they want to push into their repositories, into their SCMs, they are free with any of the vulnerabilities. So that's what we are trying to do here. Now, build with security focused CI/CD workflows. Now, security drives our CI/CD process. As August was just explaining, that in Red Hat, we don't have security at the end. Every stage of the building process has security aspect attached to it. So that is the thing which we learned in our development cycle. Now we want to bring it to our customers so that they can build their CI/CD workflows with security focus. Now, safety checks are everywhere in our pipelines. So one of the things which we want to do with the security is bringing SBOM, or software bill of materials. Now, software bill of materials, bringing the software bill of material is basically, it is a list of all the softwares, or of the all the ingredients which you are bringing in, which you are using to write your applications. It clearly details all the components in the build, allowing for the transparency, allowing for easy tracking of each element. And this also makes sure that it is easier to identify that the potential vulnerabilities. So that is one thing which when we are building our code, we generate a SBOM, which is software bill of materials, which will have the list of all the libraries which have been used, which source they are coming from, who is the author of that particular library. You will have all that information. Now, it is, as a part of the executive order, it is part of the compliance. For every software, SBOM needs to be generated before they gets deployed. And also it can, if you have list of all the libraries, all the authors, everything in front of you, your auditor teams, your security team can easily figure it out. Oh, this particular library has some vulnerabilities, don't use that, use this library which is coming from a trusted source. And they know that particular part as well. Now, another thing is origin checks. We want to ensure that we know the source of the software which they are using. We want to know the source of the build images which they are using. We can build up the deployment rules, which with the secure guidelines. We can continuously scan the codes. We can sign and trust. So Red Hat has been working with SIG Store, and with six store and bringing something which for signing. Okay, now we can sign our code. So as soon as the developer pushes his code into his SCM, into Git repositories or whichever SCM you're using, you can sign that code so that if somebody looks at the code, he knows this developer had written the code and it has been signed. We want to bring the signatures for distribution of the images. So after that particular code is built, and we want to distribute the images, after we build that those images, we want to sign those images using cosign again, which is part of OpenShift pipelines, using Tecton chains. And we are working with six store cosign, and we are supporting them, and we are using that particular tool to sign our images for distribution. So if you remember, when I was talking about Red Hat 30 years, we were signing it with GPG signatures. Now we are using the same concept to sign our container images using six store cosign. So that's the
Nice.
experience which we learned. That's what we have learned, how to distribute our RPM packages. Now we are bringing that to our customers. You want to distribute your images, you want to keep them secure, you want to know from which authentic source they are coming from. After building, sign those images and then distribute it, and people can verify all those things. And we also are bringing the safety gates, which are barriers ensuring that the secure and quality work only progresses to our uh, clusters, to our applications which are going into productions. Now, okay, we have done the coding, we have signed our code, we have looked for the vulnerabilities, we have built our images, we have verified all the images are good, we have signed them. Now what? Now our applications are running in productions. What next? Now it comes to monitor them. The applications which are already running in our environments, we want to monitor those runtime applications. We want to know the real time vulnerabilities, because every day a new vulnerability is going to come. Every day a new common vulnerability, a CVE will be released. So how we will know that our running applications are not getting affected with them? So we have monitoring, real-time monitoring. So our security doesn't just is for end post deployment. We will be doing the continuous security monitoring. We will always look out for anything which is any software piece of software which has a vulnerability during the runtime of our applications. So for that, we have a tool, Red Hat ACS, Advanced Cluster Security, which Tyrell will be showcasing in his demo. And he'll show you that how ACS is not just helping to scan the images, to find the vulnerabilities during the deployment time. Also, he will show you that once the application is already running, then how ACS is going to scan, will look for any new vulnerabilities which are coming in. Okay, so last slide. Sorry if it's too long. So that's my last slide, and then
No, it's good because what you're really showcasing here is the complexity of the problem, right? So if someone's watching this and they're thinking, "Ugh, there's just too much," yeah, there is.
Yes.
It's so much, and then you'll see in the demo, it takes a lot to look after all this, but we can't leave anything out, because if we do, there's your gap, there's your breach, there's your problem. So I think this is important that we take the time to understand what's going on here. So yeah, I mean, that's just my opinion, but keep going.
Yeah.
I think
So
you're right, August. I'll just quickly add a couple of things.
Yeah.
It is definitely too much, but going through everything that Prakar's been saying, it also assures everyone that security focus is in each step, right? How he discussed. We look at the code, and if there is a vulnerability in any of the library or dependency, it pops up right there. During the build, it is attested. There is a log. There's a ledger. It's GPG signed. In monitoring phase as well, whether it's running, what we say it's running is there, we can see it. So, it gives everyone that assurance that yes, security is looked at right from the beginning, right?
Well said.
Yeah.
Yes.
Okay, so the last one, we have this layered security throughout the stack, as Dave was just discussing. It's not just about deployment, build, it's the layered security throughout. So end-to-end security from code to build to monitor. We have integrated application security checks. Our CI/CD workflows are security focused right from the inception to deployment. We have a detailed oversight, whether it's a library, runtime, containers, entire network. any elements we can watch. We are looking for the security in there. And open source secure software risk profiles, we stay informed about all the open source software risk profiles to ensure that we are always a step ahead. And we also have the flexibility. Our solutions are versatile, and whether it's a physical setup, whether you are running on a virtual environment, you are running in a hybrid, you're running on a cloud, you're running on any cloud, we are just, you can bring all this, the solutions which Tyrell will be showcasing anywhere. Okay, let's the last slide I have before I hand over to Tyrell, when Tyrell is waiting and his his fingers are like, okay, I'm ready. Okay, so we have this high level architecture. So what we have done, we it's a fictitious application which is called Cool Store, which we are deploying. We are having a hub cluster where all the security components which I was talking about. So we are having Red Hat Quake, which is a secure registry where we want to store our images. We have Red Hat OpenShift pipelines for our CI. We are using OpenShift Data Foundations as the backend for data for storage for Red Hat Quake. For Sonar Cube, which is an open source tool, which we are using for scanning the code smells. Any code smells are there, so which Tyrell will be showcasing. We are using that. We are using HashiCorp to save any secrets, any sensitive information. Then we have two clusters, dev and production clusters, where our application will be deployed. And both the clusters, we are running Argo CD or Red Hat OpenShift GitOps. And that particular application, which is Globex app, is using Kafka for streaming. So that is the one which we are not focused for now. We are just focused on the security. Now let's bring Tyrell in, and he'll showcase the soft secure supply chain pipelines.
Yeah, no, it's a great lead in because so I'll pull that. It's a great lead in because now we have the scene set. We know the problem. We have the scene set. Now we have to figure out how does this thing really work. And we got the person here to do it. We got the team to show us how to do it. But yeah, Tyrell, why don't we hand over to you and let's see it.
Cool. Thanks, August.
Sure. There we go.
Right. So for our supply chain, software supply chain, we're using OpenShift pipelines. It's a very, if you look at it, it looks very complex, but it's very simple in terms of what it does, right? We have as Prakar mentioned, we've got an application called the Cool Store application, which is an application that is made up of other small applications. So it is a microservice architecture. Now, this pipeline specifically is going to build the front end of our application for us, right? So it's an Angular source code which is built and with Builder, and a container image is created for that and then deployed to an OpenShift cluster, right? So just to give you an idea how that application looks, it's quite simple. It's a front end of a Cool Store. You could log in and here, and you could add stuff to your cart and stuff. So it's pretty cool, nifty stuff, just to showcase our our environment and our stuff that we're going to show you today. All right, so this is obviously built in OpenShift pipeline. So this is, if you can see my screen, this is the actual pipeline that's going to build that container image for us, right? We're using a concept called pipeline as code. So the pipeline resources are actually stored in a Git repository, right? So we could take this code and deploy it into any OpenShift cluster, right? And have it execute on that cluster, right? So we just pass in specific parameters into that pipeline, and it would build your source code, right? For this one specifically, we passed in the Globex UI repository for us to build, right? So with any source code change or anytime a developer pushes source code into the repository, it is actually it will kick off our pipeline for us, right? So there's a webhook that is triggered from any push to the repository, right? So if you've got a list of developers, what we did in this example was that we created a GPG key for each of those developers, right? So that means that we actually trust those developers. So we added the public key in our Git repository for us. So any part of, so when you're going to build code, we want to make sure that we're building code that's been checked in by someone we trusted, right? And not by anyone that we don't know, okay? So just jumping to the pipeline. So the first step we're going to do is, as soon as a developer checks in a change, it actually fetches the source code for us. So the first step is actually pulling the source code into our workspace so the pipeline can actually work on it, right? The next two steps are run in parallel, which is the scan source and the verify source. So Prakar mentioned an open source tool called SonarQube. SonarQube is actually called in this step here, right? So it's pointing to our source code and says, run a scan on this source code and tell me if there's any bugs or any code smells that are existing in this code, and and print them on the screen. And what it also does is actually creates a report for you on the SonarQube front end. So you could log into SonarQube and you'll have a project called Globex UI created for you, and it'll have a list of all the critical, medium, high, low, bugs or issues that it finds, right? And all of those things are configurable, but for our demo, we just use the default. And as you can see, there's not many critical. Actually, there's no criticals, so that's why our pipeline is successful, right, at this step.
Right, so otherwise it would break it there.
Correct.
It would tell you you've hit a critical.
Yes.
Yeah.
So ideally, what will happen is that this will say failed. It'll say refer to you to SonarQube. You log in, you'll see what's going on, and then your developer will go back to the source code and correct it there. Okay. At the same time, what we have is a verify source. So remember, I told you before that when a developer checks in a change, we trust that guy because we've actually pulled the GPG public key that we've generated for him into our Git repository, right? So this step here is just basically ensuring that the commit that was made by that developer was signed by our GPG key. So we've got a public key that's embedded in our pipeline that checks against the commit and says, okay, cool. The commit is verified because my public key is verified against that commit, right? As you see here, it says good signature, and we know the person that was dev user. So we're pretty happy with that. There's other few warnings, because that's not necessary at this time, but you could get rid of those. But the most important part of it was that we verified the signature, right? If, for example, someone checked it in that is not who we trust, that step will fail there. We'll stop you right there and says, I can't build the code. I don't trust you. Maybe go and speak to your boss to get you a key. Right? All right. So once we do those two steps, the next step is building our image, right? At this point, it's going to point to our source code that we've cloned and start using Builder to actually build a contain image for us, right? Once that image is built, right, we've enabled Tecton Chains on this cluster. So Tecton Chains is going to look at that image and saying, okay, cool, I know you built a contain image because with Builder, there's two specific variables or results that are set from that task, right? It's called an image digest and an image URL, right? So Tecton Chains uses, if you actually look at it here, I'll go quickly. If you look at the build sign image, there's actually two task run results that are created here, right? Tecton Chains will look at these and say, okay, cool, your task is actually spewed out this information for me. That means that I need to go and sign this image. Okay, so Tecton Chains will use the cosign. So we've actually enabled cosign to be the signing authority for Tecton Chains in our demo, right? So Tecton Chains will look into the OpenShift pipelines namespace and look for a secret called signing secrets, right? And this signing secret has a cosign key, so it's used to actually sign our image, right, along with the password, right? And then it also generates a public key for us so that we can actually verify that image. So if you see later on in the pipeline, we use the public key in ACS to verify our signature on our images. Okay. So let me just go back to the pipeline. So once this step is done, so we've actually built our image and we push it to Quay at this point. If you look at Quay here, this image was actually pushed to Quay. And at the end of the image tag, you'll see this image has been signed by cosign. Right? So,
that's great.
Yeah. So another thing that's important is that all the security issues have passed, right? So we've fixed all the problems that we had as a developer. It was 14 high issues, and now we've actually fixed it in our pipeline. Before we execute our pipeline built our image, and we're all good now at this step, right? All right, so going back, once our image is built now, we need to run ACS against this image, right? So there's 3 checks that are run in parallel, right? So 2 of them are ACS. One is an image check, so that's going to check our image signatures. They're going to check if there's any issues with the image we built, right? And the other one is the ACS image scan, right? Image scan is going to check your image to say, are you using something that's not trusted? So is there something that using from Docker.io that we don't, as you know, Red Hat trust, right? It's going to flag all those issues for you at this step, and you could actually flag them as high in critical. If there's any, for example, you don't want to use any images from Docker.io, for example, you could set up a policy in ACS to say if there's an image that contains those layers in there, we'll flag that as a critical issue and break your pipeline, stop your pipeline at this step.
So if the developers built their own image, they could be using layers from places they maybe shouldn't be
Yes.
or don't trust. And so that's where we're going to get into that. We can actually start to look at those layers and say, hey, wait a minute, this is fine, but this isn't.
Correct. Yeah. So ACS will actually print that out for you on the screen and saying, I don't think you should be using this image, or this image from Docker.io. It's very insecure. It's, high risk. Change it, All right, so those are the two ACS checks we do. And the final one is what Prakar mentioned before, is the SBOM generation. Right? Yeah. This is actually going to go and scan your Node.js application and look at all the dependencies that are being used in that application, right? And it's going to spit out a file called an SBOM, right? So this is an XML representation of your SBOM, right? It doesn't make any sense to, just looking at it, right? But what we added recently in a change, so it's got stuff like, which library using, the dependencies, where it's coming from. It's just basically like a library of your library, right? So what we did in the latest release is that, people ask, what do you do with this SBOM? What can we do with it later on, So what we did was we added a tool called Gripe, which is actually going to scan your SBOM, right? It's going to scan it. And it's going to, so once we build the SBOM at this step, we actually scan the SBOM, and it'll tell you all the libraries that you've been using and the severity of those libraries, in case, for example, right, loader utils has a critical severity. So, it's flagging you that you're using this library 2.02, which is as a critical security issue, and it can be fixed by just installing 2.03. So, for this demo, we didn't want to break the pipeline for this, but you could actually break the pipeline or stop the pipeline if you've got a critical or high issue, and which would force your developer back to the development stage to actually pick the correct libraries to go and build your application with.
And it's so easy to read. So you're saying this was just recently added, because I mean, I've been talking with you guys about SBOMs, and besides it sounding really cool, check the SBOM. Sounds like a super spy thing, but like, this is great. Like, I mean, I can deal with that, right? I can see that. I can understand that.
Yeah. It's cool. So before we didn't have it, so a lot of people ask, what do we do with this stuff? So, but now it's just an example of what you can do. So you could actually build rules around this in your pipeline to fail your pipeline, or to send out alerts to your ops team to say these are the issues. Flag them when you're in your libraries that you are pulling from, and make sure that you don't use them. So that's a possible scenario for that.
Yeah, one of the things for the SBOM was just to maintain the compliance, but now not just compliance, you can actually scan that and find out the vulnerabilities.
I think Tyrell and Prakhar make it sound really easy, but it's such a critical step. This SBOM, it could, save your bacon at the end of the day. It's so important to just see that one critical severity being missed, and you get into all those, the numbers that you spoke about, August, initially, right? That one, one small, miss, and you could, talking millions, right?
Yeah. So that is the part of the executive order as well, the one which I was talking about. So SBOM is one of the parts of that compliance. To maintain that compliance, they have to generate SBOM for every piece of software they are going to put in US federal.
Right. And other nations will follow, or need the same thing. Europe will do the same. Australia do the same. See, superheroes, I told you, this is what we need.
Cool. All right. So once we've generated our SBOM and got the report out, we in a position to safely deploy this to a dev environment. We want to test our image now, right? So this next step is that what happens now, we've got our CD process sitting outside of this. So we don't manually push our image from the CI into an environment. We've actually updated a repository using which Argo CD points to, and basically we updated the repository with a new image tag, right? So Argo CD will pick this change up now, and notice that our repository has been updated, and deploy this to our development environment, right? So if we look at this image here, we've added this tag in our pipeline, right? So to say that this is what the developer has actually done in the source code. He's added this tag to the front end, and now it's built the image. and it's deployed to a dev environment. If you look at what prod looks, it doesn't have that, right? So this is the
Mhm.
prod instance, and it doesn't have that tag, right? Right. So the important thing now is I've shown you the build state, right? So another thing that ACS can do is that it can prevent your images or deployments into your environment if your image isn't signed. So what it does is it will check the image that's in your deployment, scan it to determine if there's a signature on it, and if the signature doesn't is not what it expects, it will stop that from happening, right? So that's pretty cool if you've got developers that are just deploying whatever they want onto your environment without knowing, right? So you can force your developers to make sure that they use signed images that are trusted by your organization to your environment, right?
Yeah, and it makes sense because developers need to get their job done, and maybe we don't force, we guide them to use the correct images, and then people learn, right? Because I think that's a great thing is we can actually start to educate the work, that the development team as to why they need to do this, because here they are seeing it going, oh, I didn't realize that.
Yeah, correct. So what I did was for this demo is that I built another pipeline called the Globex UI unsigned pipeline. So this here is pretty much a very simple version of the previous one. All it does is pulls the source code, builds the image, pushes the image to dev, and does an ACS check, right? So what I did in this specific pipeline is that I intentionally left out checked on chain signing. So I forced the image to be built without being signed, right? And then I deployed it to dev at this step, right? And then what I did afterwards, after I deployed it, I'm scanning the image that I deployed using ACS. I'm doing the same check I did in the previous step. And then it says here, look, I can't build this pipeline. It's not successful because the policy that ACS triggered says that that image isn't signed. So it'll break your pipeline if your image isn't signed. So that's one step, right? The other thing that I've included was the trusted signature policy on deployment, right? So if you look at this deployment, it's actually deploying an unsigned image. So when I push that image to dev, this is the actual deployment that's using that image, right? And if you look at the events, ACS admission controller is saying, I can't deploy this now because the trusted signature policy is prevented from deploying. Okay, so I can stop I can prevent anyone from deploying unsigned or untrusted images to my OpenShift environment.
All right, that's cool. So that ACS stopped that. I'm viewing the deployment in my OpenShift console.
Yeah.
It's all working together. Oh, that's really cool.
Yeah, that's pretty nifty what it can do.
The policy, that's really cool. Yeah.
All right, so we sorted out with dev. I just showed you what ACS can do in terms of the signature verification. Let me go back to our original pipeline. So we're here now. So once we deploy to dev, what I added is a very cool feature from ACS. So there's another feature that ACS can do is that basically it can scan your deployment file, so your actual OpenShift deployment file, and can pick up any issues that may arise. Right. For example, in this example, I've intentionally left out the request and limits for your deployment for your container. Right. So I've set it as a medium severity, and just for alerting purposes, it's telling you that, oh, you know what, when you created the deployment file, you forgot to put in a CPU limit and CPU request, right? So ACS can give you that flexibility. It can tell you, you're not adhering to your development, structure, rules, or whatever the ops team have provided. You need to provide these specific values in your deployment. It'll stop your pipeline from deploying, from building at this step as well. So you could add, that's a pretty cool thing that we could do, and just to enable your developers to build things correctly,
intelligently.
Yeah. That's neat. That's really neat.
All right, so along with the ACS deploy check, we've got I've just added something from Sixto. Sixto has a tool called Recall. What happens when you sign your images with cosign? It pushes metadata about that signature to a third-party service called Recall, right? So it tells you about the time it was signed, who signed it, the information around the signature. Basically what you could do with this is that if someone is wants to use your image and doesn't have your public key, or doesn't have access to vital information. For example, you have to give your public key out to someone for them to verify your image. If they don't want to do it, they could actually query the record library and ensure that this image comes from a trusted source. So that's just an additional thing that we added. We've got ACS to do that for us in our example, but this is something that that's available by the Sigstore environment, open source, which allows you to actually look at the signature metadata. So
Yeah,
what I got is,
this is something which is making easier for the customers who wants to develop the code or container images for open source softwares and want to push it to the public repositories. It's for them it is very much easier. Like they don't have to get the public key. They can go to record, find in the ledger. They will know that exactly this particular image was signed by XYZ company.
yeah.
So
So
It's great because it really fosters that sharing and builds. We keep saying it, but builds the security step in. It's not now. I mean, you'll still check things, but it gives them that extra assurance. It's cool.
yes.
So this step is just showing you. I'm querying the record store for us at this step, and it shows you metadata about your signature. So it shows the image registry repository that you're pushing to, the digest of the image, the timestamp, the task run, the actual task run ID that was used to create that image. So it's a whole complex, not actually complex. It's a very thorough view of your signature, which people can look at, and if they want to trust it, they could use it. So it's just something for them to settle their mind, basically, right? So once those two steps are done, we're ready now to actually prepare our deployment for production, right? Now production is obviously a very secured environment. We don't want to do the same thing we do with dev, is actually push it directly to our branch and have it available in a development environment. What we do is we create a pull request, a branch, and a pull request on that branch. So that basically means that someone with the correct privileges will log in here. You can go to the pull request that we created here, and then commit this, right? And then basically this is merged into our branch. Right? Argo CD will pick up the change now that we've merged into a new branch and deploy the image to production. Right.
Really?
Yeah. So I know we're running out of time, but what we could do is, if you want to, I haven't showed you how we kick off the pipeline, right? So
let's do it.
What we could do now is I'll just give you an example of how this is done. So just for example, a developer wants to make a change. I'm just going to edit the README file for ease of use. So I'm going to go and test. I'm going to save this. I'm going to push now to my, where is this? Yep, I want to push this to my repository. And then now it's actually pushed to my Git repository, right? Now, if I look at my pipeline, this should automatically kick off a new pipeline.
There it goes.
Yeah.
Really?
So that's pretty integrated with your developer, your Git repository, and your CI/CD pipeline. Yeah.
One of the things which we want to bring in here is we don't want to overload the developers. The developers are there that they can do best is they develop their code. Rest of the things we will automate it. We'll take care of it. OpenShift has all those tools to do that for them, so they don't have to worry about this.
And that's what I was thinking is, how do you remember all this, right? As a developer, imagine the context switching and I mean, even I think in the operations space as well, there's room for this, but just with the developers who are essentially writing, they're very in that mode.
Yeah.
Imagine the number of mistakes they're making if they're dropping out, they're coming back in, and they're dropping out, and they're coming back in. To take that away from them, but to have that level of checks and balances and complexity behind it is just brilliant, isn't it? Right? Because I mean, and as a developer, which I'm not, but I would feel much better. I mean, imagine, if you had pipelines for like raising a baby, right? And you had all these checks and balances in there as you went through their life, and it was like, oh, well, when they, they start eating solids, you have to do this, and it just gets done for you, and you could just focus on parenting. Wouldn't that be good? But that's a weird example that we probably don't want to investigate too deeply, but because that goes into AI and robots and scary things like that. But I think this really calls out the importance of letting them do their work and do it well, and excel at it. So I love seeing all these pieces.
Yeah, it's pretty cool.
Yeah,
it certainly is. And so I mean, it's really neat to see. And this is all coming as part of OpenShift and that.
yes.
In the
So
package.
all most of the tools which we have shown you is a part of OpenShift Platform Plus. So Red Hat ACS, Red Hat Kopi, OpenShift platform, OpenShift pipelines, Argo CD is OpenShift GitOps. So they're all part of OpenShift Platform Plus SKU. And some of the tools like Sift and Gripe, Red Hat is supporting them as open source tools. We are trying to get them as part of our offering, which is Red Hat Trusted Application Pipelines. So that's the idea. Some of the tools like SonarQube, they have their own way of support. So if somebody wants, like SonarQube is just an example for us to show you. Okay,
Yeah.
Gripe is just one of the examples. Like maybe in future ACS can do that or something else can do that. So
Right. And so it's not only like it's pluggable, right? So
yeah.
we can add, if you're working, if you're an existing business and you're like, but our developers do know SonarQube, so let's use it. Yeah, go ahead, of course. The point is to make everything better together,
Yes.
to make it all kind of, because why? Because we need developers to make good code so that good code gets out there and customers get what they need safely. And I think that's what we're really showing here is, you know, whether it's where, it doesn't matter where it's running, we want to make sure it all works together. And that's the other thing that you guys called out that I love and always love to talk about is that this runs the same wherever you want to do
Yes.
it. You can do this on premises, you can do this on the cloud, you can do this in all these different places, and it runs the same. We get that consistency and portability. And so I think that's really neat.
I think it's a win-win for developers and consumers. There's a one-stop shop. Everything comes into one place. Developers can write quality code, hassle-free, not worry about all these checks and balances. And at the end, someone using this, is rest assured, everything's been taken care of, and you have all the logs and the ledgers to check if you were to. Really pretty brilliant.
Yeah.
Yeah, I really like that, Dev. A win-win for developers and consumers. I think that's a nice statement that kind of reminds you that we're actually all linked, and when we're all winning, it's great.
Yeah.
Yeah, no, that's really good. So, do you have any more to show here, Tyrell, on the demo, or we've? I mean, I know it's still running, but we've basically seen the bits and pieces.
Yeah, that's my side. Yeah, I'm done.
This is great. Cool. Let me just pull that off. We're getting lots of rain here in Sydney. It's kind of exciting to finally to get some rain after a little while. Well, there you go. We've had a great look at the story behind Trusted Pipelines and the understanding of security at every step kind of built in. It's like, something, no matter where you go, you have it, and something we love. I think you've basically helped with all those fears about the numbers and stuff. I don't know. I'm sorry, guys. I don't know if you've solved my problem with the Broncos. They lost, like I said, by 50 points, and it's going to be a long season. But I feel a lot better that when I'm accessing their app or playing fantasy football or whatever I'm doing, it's probably going to be done safely, and I'm not going to have my details compromised. So, we take the wins where we can find them. So I think that brings us to the end today. One thing I do want to remind everyone who watches the stream and rewatches, right now we have Red Hat Summit Connect going on in APAC. And this is the team behind the demos that you'll see if you attend one of these events. They provide the environments, the support, and a lot of the knowledge to back our Red Hat teams and make sure that as customers, you're seeing our software and our products as they really are. So, try to come along to one of those. They're all over APAC. There's 9 or 10 of them. Some are done, some are still happening. And of course, as well, we got tons of other shows that are streaming. I know Europe's waking up now. So, there's a show that runs in Europe. Check these out and enjoy them. And beyond that, I'm so privileged to have had these guests. It's great to have everyone back. I can throw it around the room one last time to wrap it up if you like. Prakhar, I don't know if you have anything further to add, but I just really appreciate you being here.
All good. That's develop and secure and trust.
Tyrell, I can see you love this stuff. I mean, I feel like, I should hire you as a developer. It's terrific.
Yeah, it's pretty nifty stuff. And, the stuff that Red Hat's been bringing out, it's really cool. It helps you a lot to minimize, configuring. Everything comes out of the box, so it's pretty easy. Thanks.
And we'll share links. I'll put some links in the description and stuff. And finally, Dev, it's great to have you back. It's good to be back. We're going to look at some new shows as we finish off the year. I think you'll see these guys back soon because we love seeing these demos and we love really just hearing it, at the grassroots level. So that's really cool. But Dev, I don't know if you have anything else to add.
Thanks, August. Great to be back. And I had no doubt, Prakhar and Tyrell would do justice. Loved the show, loved, what the content that they shared. I think it's, we could share this, and whoever, has watched this should share it with, other developers as well. This is some really good content here. Thanks again for being on the show.
Yeah, absolutely. Well said as always. Okay, folks, we'll wrap this up and we'll catch you next time on the Kopi Hour. Thanks, everyone.
Thank you.
See you later. Bye.